Okay, so this is a presentation on this one. So this is the presentation on the homework we are uh, given to simulate the DC-DC buck converter in the piezoelectric energy harvester. So these are the parameters I used for the used. So let's briefly analyze what I did. So these are the formulas and the graph that were given in the homework PPT. So this was the equation for D. V naught is VSTO, which is 1.8 volts, and Vs is Vrect, and this is the equation L. The R is RSTO, which is given by VSTO square divided by P out, and T is T buck, which is 100 microseconds. So, and then D is basically T by ratio of TP and T buck, and the T and TP can be given by this. So the calculation I did in order to get the value of D is it looks like this, and ultimately I got the equation like this, and then I plugged it in here. So the root over of P out divided by this term. And then the simulation. So the simulation software actually did a lot of had a lot of issues. So I had to simulate. I continuously tried to simulate since Wednesday, and finally I got this two graphs. One is for Vrect equals to 2.2 volts, and which looks like this. And for Vrect equal to 5 volts, the graph actually looks like this, and that's it.
Yeah. I think you had issues. Let me.
I mean the cadence actually regularly.
Do you still save cadence results? Are you still save your simulation result?
Save simulation result.
Wait.
I didn't understand it.
Your waveform, are you still save it in cadence? Can I open your simulation?
No, you can just I just saved this. I did not save the simulation result.
Why you change your password? Is this impact 1, 2, 3, 4?
No, the first password is the first password. I didn't change any password.
You did not change the password.
I mean, it was the password before, and it's still here. I mean, I didn't change the password.
Did you run simulation here?
Where yeah, I could not simulation here.
Wait. Is he loading your simulation? Did you remember I talked with you the last time? You should check. You run in 1 second. Did you run with 1 second?
Yeah.
Here is simulation results I run. It's like this.
2.2 volts.
Yes. Equal to 1.
Completely opposite. Actually, ran it again, and it gave the same result.
So you did not run with 100? How much is?
I did run it 100.
So you can see red is for 1 microwatt, right?
Mm-hmm.
So it's take longer time to be
Stable.
stable. So maybe for 1 microwatt you might need more time.
Mm-hmm.
Try to checking your waveform, but why is not loaded? which I will open again. Next week, can you have meetings when it's your final exam? Right? When is your final
Yeah.
exam?
Yeah, my final exam starts from 12, 2 weeks from now. Actually,
So-
like in the next meeting next week, like it's good. It will be good if we don't have meeting.
So we will skip next week and next week, right? This week and this
Yeah,
week.
this 2 weeks if we keep off. It will be really good.
Okay.
Thank you.
So I think we quite late with schedule. We start to go.
Actually, like in summer, we can actually work more than once a week. If you are okay.
Yeah, in summer you guys have more time, so we can go faster, right?
Yes. Like
Yes.
we will not have any studies or anything, so like, we can actually do more than once a week.
Yeah.
So last 2 week I
Anyway.
up to my year with material to guys. So it's so busy. So next week I will try my best to
When will
do
you
more
come, by the way?
simulation.
Sorry, can you speak again?
Last 2 week I up to my year with material to guys. So next week
Uh,
I will try my best to simulate more.
Yes,
Yeah.
but Ryan cannot join next week and next week because of final exam. So during these 2 weeks, you should finish all simulation.
Okay.
And then
Yeah.
in this week, we will go to the next step. Next step, we should start with control circuit. Control circuit. What you have run is just this. Then we have comparator and this power control and register divider, right?
Yes.
So I will give you my work. I did have the similar, not the same, but the similar target control. And then you guys have to make this. And for comparator, I think you can simulate, right? The schematic is on here. This is, you know, PMOS, NMOS, right? PMOS, the angle is go here, and the NMOS, the angle is go out here. So you can just connect.
Bro, I have a question.
Yeah.
I see parameter in is C mode and N mode. It suggests two divide with 1.5. What is mean?
What? 0.5?
To divide with 0.5 as well. The 5 divide with the 0.5.
This is
Oh.
length and width over length.
Yeah, okay.
So in MOSFET, you have width, right? Width and length, right?
Okay, I got it.
Yeah. 0.5 is 500 nanometer for length, and 2 micro is 2 micrometer for width. So you should change 2 micrometer here.
Okay.
Got it?
Yes, I got it.
Later, I will give you a comparator I made. Is I think now it's quite difficult for you to understand your whole circuit, but you just need to know your input and the output. This is digital output, right? Just low and high, like Ryan already. Yes, what you need to consider is just you put an input and you get output like this. I think for your knowledge now is that it. Later, when you study more, you can come back and learn how the circuit inside work. Okay?
Okay.
For making your own system work now, you just need to understand the input and the output. That's it. But let's see this one first. Do you see it, Ryan?
Yes.
Your 1 microwatt have not settled to stable. They should be stable and like this, so your results will be correct. But here is not stable, and
How to stable them? How to stabilize?
you should run in longer time.
How to do that?
But here is still over 1, right? How much is this?
It's 1.02 or 1.02.
Here is 12, 20, so maybe 10, maybe it's 10, right?
Mhm.
So it 10, so maybe just graph will be like this, and it's have not stable yet, so it will make so I don't know why your simulation need more time to be stable, because right, my results seem stable faster than you. Do you see it? Your case is more steep, I think, right? So you might need longer time to run. So maybe 10 microwatts, maybe is will look like this. So you might need to run more and more. Now in 1 second, but
By run
it
more by being like by
maybe
running more. What do you mean?
you should run until 2 seconds or 3 seconds to check.
How to do that? How to run for 2 seconds?
Here, I will run it 3 seconds.
Okay.
Okay, later you can check result 3 seconds.
Okay.
Later you can check how it's work. Okay, got it?
Got it.
Okay, so anyway, you understand how your buck converter work, right?
Yes.
Basically, and how is the relation between voltage and your duty time in the buck converter. Now in here, we don't control it by circuit, we control it by calculation, right? We calculate it and we put it in to make the voltage regulation. But for the circuit design, we should change by the circuit. It's by the power control. In here, right? This will change the delay, and then it can change the TP and TN, right?
Yes.
Yes. So next we need to make test band for comparator power control and register. So in my previous work, I have a comparator. I will show you. My comparator is same type. So do you remember in our comparator what kind of comparator we use? Digital or analog? In our case.
Analog?
In our case, analog comparator? Really?
Discontinuous.
Not analog, sorry. It's dynamic. Dynamic comparator. So dynamic comparator will have a clock, right? It will have a clock to control here. And for the static and normal comparator. Maybe here is continuous comparator. Ours in this case in our case is discrete, right? Discrete comparator means it have clock. It operate with the clock.
Okay.
And continuous time comparator is doesn't have clock. So if does not have clock, so it's always work and consume power. So power always be consumed because no clock. It will consume more power than the discrete time. So for discrete time, clock like this.
So it is a comparator running when the clock is a 0 or 1.
Yeah.
Or
Compare later
it's-
only work at the rising as a clock, high state
okay,
of clock. Only power consumed here. And in the case of continuous comparator, power will be consumed in all the time. So it's consume more power. That is the difference in our case. So in my work, I already use a comparator. Comparator like this. Do you see it? It
Yes.
is quite here. So what do you need to consider is just input and the output, right? The circuit inside like this. But what you do is draw the schematics like this paper, right?
Okay.
Now you don't need to understand how it's work. Just draw schematic like this. Use my schematic for reference. Okay.
Okay.
My schematic, my comparator is the same style of this comparator is a little more complex, but you can use PMOS. You can use PMOS and NMOS here to draw the schematic like this.
1, 2, 3, 4.
Okay.
Okay.
Your work is use PMOS here and NMOS here, and then you change your parameter with width and length from the paper and simulate it. So I will run this comparator.
I will do it after the 2 weeks, right?
Yeah. After 2 weeks.
Okay.
bro, please send the test pen at the computer. So
Yeah.
I want to test this liquid. Uh-huh.
I will send my comparator later. So
Okay.
we will have V in here. V in plus and minus. Here is V in minus. Here V in minus is I fix it. So you can see this will be negative. Negative mean minus, right? This is V minus and V plus. Positive is plus. Okay, it is an input. Input here. And the output is here.
So maybe Winslow.
Actually, in here you only see one output. So they are putting plus here. So I think the output they use is here. Output plus, right? So your output should be here. Plus. Okay, you got it? So
Yes.
this comparator will be like this. Plus, minus. Here is recuse buck. So your output is here. So your input plus is here, and your input minus is here. Okay, so you got it?
Yes.
Yes, schematic. So when your voltage V plus here become higher than V minus, so mode here, mode is the output, right? Mode is in the green. Okay.
Okay.
It will go high when V plus larger than V minus. However, why is the output high state here is only small 56 nanosecond, because the clock IQ here is only 2 microseconds. So output pulse also small when if I change the clock here. I know clock here. If I do is at 100 microsecond, and then run it. Okay, when I change to larger power wave from 2 microsecond to 15 microsecond, the output will be correct. almost output pulse is similar to the clock. Okay,
Okay.
so you remember you should consider the power weight of the clock also to run. Do you have any question?
No. I think my problem is current due to current, so I will fix. I think it's not have problem with parameter, so I will try to fix
Yeah,
in the weekend. Okay.
yeah. After this meeting, I will send my comparator for you. Okay.
Okay. Thank you.
Hello, Ryan. Are you here?
Yes, I'm here.
Do you have any question?
No, I will do this after my final exams, right?
Sorry.
After my finals, I will do this as well, right?
Yeah. After final exam, you will do it.
Okay,
You will finish exam at 16, right?
at 16. Yeah. After 16, like we can actually sit and reschedule. Like after final, I can actually do more than once a week,
What?
maybe
what
twice or like more than one time a week, maybe two time or 3 time a week.
No, I think it's too much. You need time to run simulation.
But I will not have any study to do in like summer, so.
You can read the book. And
Oh yes, okay.
Yeah. I think 1 a week meeting is okay. If you need, you can go to lab to meet me.
Oh,
I
okay.
think.
Okay.
If you have more time, yeah.
Okay.
So anyway, we should finish in June this all simulation. We should
okay.
one week will comparator and other week will be power weight modulation. So comparator should be this week, and the last week of June we should finish this. Okay, so we can make your whole system. Okay, got it?
Yes.
Okay, got it.
Yeah, okay. If you don't have any question, see you in next week, right? Should be here. 33, 23. Okay.
Okay. Well.
Okay. Okay. Bye bye. See you.
Okay. Thank you
Bye-bye.
so much. Good night.